Alright, let's go. Let's do one Leetcode problem, ideally within the hour. Alright, so the stream will end hopefully in less than an hour, ideally. You know, I'm like time boxing this shit. Gotta do some other stuff afterwards. I spent some time writing a little bit of a script, halfway done possibly, for a YouTube video that I'm concocting. It is some here. You just saw a little sneak peek, but now we will focus on set matrix zeros. And we can technically just close this. All right. Set zeros in matrix. Now this is a math and geometry problem. Okay, given an n by n matrix of integers matrix, if an element is 0, set its entire row and column to 0. You may update the matrix in place. You must update the matrix in place. Could you solve it in O of 1 space? Okay. So for the input matrix, 0, 1, 1. Okay. Example 2. Right. Now, I'm thinking like you still need like a 4 pointers. So if you need a if you're going to do a 4 pointers, how would this happen? Well, we need maybe it's a 2 pointers, but one on each axis. Could be that. And then you go down. I can see that. So, my thinking, I have a thinking. We're just gonna try it. I don't know how best to articulate this, but let's just say left and top for, let's see, so this is an m by n matrix. So rows equals matrix. Should I actually call this rows or should I call this yeah, rows. Alright, we'll call it rows. Matrix of, sorry, let's see, len of matrix. This would give you the rows, and the columns is the len of matrix with 0. Now the thought process is for all of these combinations, right? So for I in range, so actually should I say for X in range of calls, for Y in range of rows, matrix of YX would give us what we need. um, if this is equal to 0, then L is equal to left is equal to left is so left and right. It's going to be y. Wait, x. Top is equal to y, and you're going down and up for said t and said l. Trying to think how this would be done. I guess if this is not equal, then you would just continue and you would do these. You know the entire length, right? Yes, you do. So for, I guess you don't even need, okay. For I in range of rows, so for each of the rows, matrix given row given column is equal to 0. I guess if this does not equal to 0, then it should equal to 0. And then it would reduce the need to check anything else. Is that right? If you got a 0 there, then it would cause the others to be zeros as well. Right. And once you reach that 0, you don't ever want to scan it again. Visited, maybe? So ix, or should I say xy? Alright, xi. Just say it. Xi, alright. That means we need a visited set. And then it would mean that or wait. If it is equal to 0, then you would do this. If it's equal to 0 and it's not been visited, or it's been visited. I think that's it, right? Can't think of anything else. We'll see. Ah. Right, so that only did the x position. For I in range of calls, if matrix of visited.add IY. Something about this seems kind of off. It's accepted. It's accepted. It's accepted here, but is it accepted in Leetcode? It does say, can you do this in O of 1? Could you solve it in O of 1 space? Whereas I solved it in O of n space. O of nm space. And nm space. And okay, still accepted, but yeah. Apparently you can solve this in O of 1 space. Alright, so we got to look at the solutions on how to solve this in O of 1 space. I solved this problem in O of n times m space and time complexity. But there is also a O of 1 space solution. Right, and that is the problem that we will look at. Pretty easily. Okay. I will say just to look at the solutions to see what the alternative is. Mark. Right. Mark is like my visited set. Iteration. Space complexity is O of m plus n. Really? Ooh. Interesting. And then space optimized iteration. So iteration. There is a space optimized version of iteration. I gotta understand that.
Hey everyone, welcome back, and let's write some more neat code today. So today let's look at set matrix zeros. We are given an m by n matrix, and we want to go through every element. If we see that an element is 0, we're going to set the entire row and the entire column to 0. So for example, we're given a grid. There's only one 0. So what are we going to do? We're going to set everything in the column to 0. We're going to set everything in the row to 0. And then we see the output is exactly that, right? We got some zeros. And then this is going to be our output. And as you can see, there's a bunch of ways to solve this problem with better and better complexities. So I'm going to show you the bad solutions and then show you how you can use that to get the best solution, because it's actually pretty intuitive. So first, let's say that this is our input array and we declare a copy of that array, a copy of that matrix, right? So then what we can do is go through every position, right? So the first one is a 1, so we don't have to do anything. Then we get a 0. What does that tell us? That tells us that the entire column is going to be set to 0 and the row is going to be set to 0. So why can't we just do that in place? Like, why can't I just put a 0 here and then a 0 here and now a 0 here, right? Because there's actually a good reason, because so far we've checked off these spots, we checked off this spot, now we're over here, right? But we replaced that 1 with a 0 now, so now we're going to end up making this a 0 and this a 0, but that's not really what we want to do. And that's the reason why we start off with a copy. So when we make changes, we're going to make changes to our copy, and when we read the values, we're going to read from our input. So remember, we did see a 0 over here. So in the copy, we are going to update the entire row. So this is going to be a 0. This is going to be a 0, so every value in the row, but we also have to do the column. We see this is already a 0, but this is going to be changed. So now we made changes to the copy, so this is a 0, but we see that this is still a 1, right? Because now when we go to the next position, which is this, we see it's a 1, so we don't actually have to modify this column and this row, right? Because we haven't even read this value yet. And now we're just going to continue. So this is the next position in our matrix. It's a 1, so we don't have to do anything. And this is the next one. It's a 0, so it's time to set the entire column to 0 and set the entire row to 0. So in our copy, we see that we actually already did this column. So this is kind of an example of the repeated work that we're having to do, right? It kind of shows you that maybe having a copy is not the best solution, but we still need to update the row. So we're going to change this to a 0 and we're going to change this to a 0. So next we go to this position. It's a 1. We don't have to do anything. And then we go to the next position. This is a 0, so it's time to make some changes. We're going to set the entire column to 0, and we're going to set the entire row to 0 in our copy. So we see that this is already a 0, so this is the only other value in the output that needs to be changed to 0. And we see that the column has already been set to 0. So clearly having a copy of the input array takes m by n memory, and it's also not the most time efficient algorithm either. So how can we do better? We're noticing for every single cell in our input, we're potentially having to update an entire row and an entire column. Can we prevent this repeated work? Yes, I'm going to show you how. So we see that we actually have a fixed amount of rows, right? Let's call that M. We have a fixed amount of columns N. So worst case scenario, all we're going to have to do is make sure that every row is set to 0 and then every column is set to 0. So as we iterate through every single value in our input, let's not update the copy. We actually don't need the copy. We need less memory. We can have one array for the number of columns and one array for the number of rows, and then we can mark these whether we want to fill in zeros or not, and then at the end we can actually fill in the zeros in our input array without even needing a copy. So let me show you this algorithm. So we have a 1, so we don't have to do anything. So this empty indicates that we don't have to zero the row or the column. Next, we see a 0. So what are we going to do? Well, we're going to say, okay, in this column, we're going to fill it with 0. So this is some work that we have to do. In this row, we are going to fill it with zeros, but we're not going to do it yet because we don't want to overwrite this value that we haven't even visited yet. And we definitely don't want to overwrite this value yet, which we haven't visited yet. Next, we go to this position. It's a 1, so we don't have to do anything. This is also a 1. This is a 0, so technically we have to mark this spot, but we already did that. We already know this column's going to be set to 0, but we want to say that this row needs to be set to 0. We're not going to fill the zeros yet, but we're definitely going to mark it. So this is a 1, we don't do anything. This is a 0. We know that this column has to be set to 0, and this row has to be set to 0. Now, technically, we see that every row is going to be set to 0, so therefore, like, the entire matrix is just going to be 0, but we're still going to continue our algorithm. So this is a 1, we don't have to do anything. This is a 1, we don't have to do anything. So now what we're going to do is we're going to look at this memory, and it's going to tell us which columns need to be set to 0. So we see the first column does need to be set to 0. We're going to do that. The second column needs to be set to 0. We're going to do that. The third column does not need to be set to 0. Next, we look at the rows. The first row needs to be set to 0. We mostly already did that, but don't forget about this one. The second row is going to be set to 0.
Very cool. Very cool.
The third row is going to be set to 0. And obviously the entire matrix is now 0, but the advantage of this is the memory we used, we didn't need to create an entire copy, we just needed 2 arrays. So the memory complexity is actually big O M plus N, where these are the dimensions. The time complexity is M by N, because we're really just iterating over the entire matrix at most 3 times. One where we iterate through every position, one where we fill in the columns, and another time where we fill in the rows. And I didn't tell you the time complexity of this one, but it is actually greater than the time complexity of this. So this is actually a better time solution and a better memory solution. Now, my only question is, can we get a O of 1 memory solution? We know the best time complexity we can do is M by N, because we do have to iterate through
73 set matrix zeros dot pi. Double check.
Through every single position in the matrix, but we can save some space. Is it possible? Yes, I'm going to show you how. Is there a way where we can take this array and put it into the matrix so we can do this in place? Is that possible? If I put that over here, is it possible for us to take this array and put it in to our matrix?
How?
The answer is yes. We can take these two arrays that we have and put them in our matrix. So we do this in place with O of 1 memory, but you see just one problem, right? Just one little problem. Notice how this position is overlapping. The two arrays are overlapping in this position, so we do need a tiny bit more memory. We just need one more cell, right? We just need one more variable, but we know that that's still big O of 1. So I'm actually, for the purple one, which tells us which rows we need to zero, I'm going to have it be one less. We don't want them to overlap. So we can get rid of this. We don't actually need the extra memory from these input arrays.
What the fuck?
We don't need this extra memory, but we do need this one single last cell because we see that there's no room for it over here. The green one took that from us. So you can see this is big O of 1 memory, right? We're just using one extra cell. That's constant memory. And so this is going to tell us whether we need to zero out the first row or not. So now we're just going to run through the matrix for the third and last time. So this is a 1. We don't have to do anything. This is a 0. So what are we going to do? We're going to mark this cell. And how are we going to mark it? Well, we're going to set this to 0, which it already is, right? And we're going to set this to 0, indicating that this row needs to be zeroed out. This 0 tells us that this column needs to be zeroed out. Next, we go to this cell. It's a 1. Great. We don't have to do anything. This is a 1. Great. We don't have to do anything. This is a 0. So what are we going to do? Well, we're going to set this cell to 0 to indicate that this column needs to be zeroed out, but it's already 0. Good for us. But we also need to set this to 0 to tell us that this row needs to be zeroed out. And you see why this solution works, right? So now we're going to set this to 0, and that's okay for us because we already visited that cell. We already saw that it initially had a 1, so we can overwrite it. We're allowed to do that. The reason this works is we start at the top left over here and then work our way down, right? We start here and work our way top to bottom, left to right. So now we visit this cell, it's a 1, nothing to do. We visit this 0, so we got some work to do. We need to set this top value to 0 to indicate that this column needs to be zeroed out. And we need to set this position to 0 to indicate that the row needs to be zeroed out, but it's already 0, which is good for us. So now we get a 1, nothing to do. We get another 1, nothing to do. Okay, so now that we know which rows we need to zero out and we know which columns we have to zero out, so all we have to do is fill in those zeros. So we start here. We know this entire column needs to be 0. It already is. We know this column needs to be 0. It mostly is. We just have to change this last value. This is a 1, so we don't have to zero out this column. Next, let's go through the rows. So this row needs to be zeroed out, so we can change this to a 0. This row needs to be zeroed out, so we can change this to a 0. The third row also needs to be zeroed out, so we can change this to a 0. Now the entire thing is 0, which is the result that we expected. But the good thing about this solution is we did it in place. All we really needed was one extra variable. So with all that,
Hold on.
nothing to do. Okay, so now that we know which rows we need to zero out, and we know which columns we have to zero out, so all we have to do is fill in those zeros. So we start here. We know this entire column needs to be 0. It already is. We know this column needs to be 0. It mostly is. We just have to change this last value. This is a 1, so we don't have to zero out this column. Next, let's go through the rows. So this row needs to be zeroed out, so we can change this to a 0. This row needs to be zeroed out, so we can change this to a 0. The third row also needs to be zeroed out, so we can change this to a 0. Now the entire thing is 0, which is the result that we expected. But the good thing about this solution is we did it in place. All we really needed was one extra variable. So with all that being said, let's finally write the...
Okay, problem with that is how is he doing it without overriding? There is something about that that's off. That what he just explained. To me, at least, if you overwrite the first one, that's a problem, right? You can do it for the second and third for sure. But you're kind of meant to do the last two last, from my understanding. Okay, but I kind of get, you know, the idea. So let's try this again. So we're gonna have in place. So we're gonna call a row, top row. I'll call it top row. Top row. Top row is equal to 0. Top row is equal to nothing. If let's say top row is equal to 1. No, nothing. Okay, for rows is equal to len of matrix, and cols is equal to len of matrix of 0. For cols, for col in cols, matrix of col, so this is the specific column, so row and column. So row is going to be just the first row. For row and column, no, we're just going to say the first row. Is that right? Is that right? Is that right? For the first row, the top row, if top row So if this is equal to 0, top row is equal to 0. And then you can break. So for col and cols, for row and rows, for each of the rows, if something, then you break. So if for row in range of rows, range of cols, okay, for this we're gonna say from 1, right? If matrix row, column is equal to 0, that row a matrix at given row at 0 is equal to 0, and then you break. And you continue for each of the columns. Wait. For each of the columns. Yeah. For each of the rows. So you're looking at for each of the columns, do the rows. Okay, then shouldn't I be breaking on... Okay, I'm doing this the wrong way, I think. So for each of the rows, for each of the rows, including 1 up to row, for each of the columns. So looking at the columns, ooh, yeah. Then you say matrix RC, if this is equal to 0, then R0, column 0. Yes, column 0 is equal to 0, and then you break. Okay. And then you would do this for the columns as well. For R in range. Okay, for column in range of cols. For R in range of rows. If matrix of row column is equal to 0, matrix of 0 column is equal to what am I missing here? So if C in columns, if the first row has 0, then that row is done. And you should also mark the column respectively. But we're marking the columns directly now. Okay. We can break out of the row for loop. Or can we break out of the column for loop?
Ooh.
We can break out of row for loop, but the column one we keep. Okay, and then add the columns. Add the zeros. So you now add the zeros by looking at so you do the rows first. Then you do the column and then you do the last row, I think. So for the row in range of 1 to rows, matrix row zero. If this is equal to 0, for I in range wait. Yes. Find range of cols. It's going to be 1 cols. Matrix of R and C is equal to 0. Then if what? If for C in range of cols, if matrix of the current row being the 0th row and the current column being C is equal to 0, for C, for row in range of 1 to rows, matrix of row column is equal to 0. And then finally, top row. If top row is equal to 0, matrix 0 column for column in range of cols, this is equal to 0. Alright. I think that should work. Oh, okay. Expected output. My output versus expected output. Shit. I gotta check if this is right. So you only check the top row, then you checked for all the other rows. And said column should also be set to 0. So for all the columns, for all the rows, row column equals 0, then this should also be equal to 0. Oh, did I mess up? Row. I can kind of reduce the duplicate code, make it simpler to read if I do something like this. If r is equal to 0, top row is equal to 0, else this. So then we'll remove the need for that. And then now for each of the columns, that should be right. My thinking is. But something is not right here. I don't know why the internet partially dropped out a little bit. This isn't even loading anymore. Refresh. Ooh. So if I didn't do any of this for now, and I just run this, we get 0, 0, and 0, 1. Ooh, wait, 0, 1. Zero, that. Okay. Run. Yeah, so this fails. I do that and run. So we have 1, 2, 3, 0, 6. 2 should be updated, but it isn't, right? So this changes all the rows, but this changes all the columns. If row column equals 0, then column at 0 should equal to 0. Oh. Okay. Wait. This is overdoing it, no? Why is this overdone now? Why is that 0 also 0? Hold on, let's just double check. If I remove this and run, what do we see? 0, 0, 3. Okay, so we should only have seen 1. That being 0. Why is that 0? Oh, okay. Because that was 0. Okay, I see. What happened to doing it in place? Ugh. Do we have to do this first? This first. This first. That second. Yeah, this first, that second. This third. Fuck, I know. Okay, I know. So this has to go here. The ordering of these for loops matter, right? So that's the key here. So we gotta remember. For C in range of calls, if matrix 0 column is equal to 0, top row is equal to 0. Then we can break. So then we check the columns and then we check the rows. Check the rows. Yes, we did it. Okay, the ordering of the for loops matter in this one. Very, very interesting. Thank you, the guy you can trust. You remember the thing spawner was pretty annoying? Yep, I agree. So this one's definitely pretty, you have to be locked in to understand the, what do you call it? Arrays, I guess. You have to really understand the matrix and be confident in that. So I do say that is quite fun, to be honest, despite being maybe annoying. But we are happy with that. This is still O of m times n time complexity, but space complexity is now O of 1 instead of n log n. Oh, sorry, instead of O of m times n. This is after looking at the Leetcode solution for this problem. Alright. The fuck? Okay. Okay. Python is just really slow for this problem, I suppose. Okay, done. We did this in exactly an hour. Let's go. Alright. That's because I did this in 2 different ways. But that's it. Okay. We're gonna stop it there, and we are now, at least in Blind 75, up to bit manipulation. Okay. We'll do that next time. Alright. See you guys. Peace.